Hello everybody, and welcome back. I hope you're having a wonderful week. Today we will be talking about method of joints. But before we move on, I want to remind all of you with an engineering degree from outside of US, I have put together a PDF guide with step-by-step instructions on how to evaluate your education in United States of America. Please just click the link below and you will be able to download it for free. Now let's move on. Here is our little truss. The problem says, determine the force in member AG for the pin connected truss shown. Instead of just calculating the force in member AG, I would like to go and calculate the entire truss to get you used to this process. Now, every time you use the method of joints, I would like to point out a few steps you have to follow. Number one, you have to identify the zero force members. Number two, calculate the reactions. And number three, calculate the force in each member going joint by joint. Remember, since we have only two equations of equilibrium, sum of forces in x and y directions are zero, you have to start with a joint that has only two unknowns. In our case, we have joint A and joint E. So let's start with identifying the zero force members. If you've watched my previous video, I discussed how to identify the zero force members. So if you are not familiar with that, please watch my previous video. So in our case, we have member BG, which is a zero force member because we don't have an outside force. And we know that these two collinear members are equal and opposite in direction. So this must be zero in order for node B to be in static equilibrium. Same with force FD, member FD. Now, once we remove these two members, we have CF and CG, which is they're also zero force members. Once we remove these four members, our truss will look something like this, which it's much cleaner, much easier to proceed and calculate our forces in each member. Now we'll have to calculate the reactions. We'll do sum of moments in point A equals 0. Results VE times 60 meters minus 50,000 newtons times 30 minus 25,000 newtons times 30. We don't have any more forces, equals 0. Resolve that VE equals 1,500,000 plus 750,000. Once we do the calculations, VE equals 37,500. Now let's do sum of moments in E, resulting VA times 60 minus 50,000 times 30 plus 25,000 times 30. We don't have any other forces, equals 0. Resulting VA equals 60 at the bottom, 1,500,000 minus 75,000, and it results, once you do all the calculations, VA equals 12,500 newtons. Now let's calculate AJ. Sum of forces in X direction equals 0, resulting HA equals to 25,000 newtons. You can also go ahead and verify your reactions by doing sum of forces in the Y direction equals 0. If I look at my reactions, 12,500 plus 37,500 equals 50,000, which means the sum of forces in the Y direction equals 0, meaning I have calculated my reactions correctly, so I can move on to step number 3, calculating the force in each member going joint by joint. We'll start with joint A. We have VA, which is 12,500. We have our horizontal reaction in tension, which is 25,000. We have member force AG, and we have this member here, force AB. I am making force FB a compression member because I am looking at my reaction. It is pointing, it is also compression, so most likely it is going to be compression just to make my job easier. So let's go ahead and calculate force AB and force AG. First, we'll do sum of forces in the X direction equals 0. This means we have FAG minus 25,000 minus my X component of force AB. Let's see how much is our angle here. Let's go back to our truss and see how much is our angle. If you look here, let me draw a straight line as much as I can here. This member CO, it's 30 meters, and OA, if you look here, it's going to be also 30 meters, which means that the angle, both angles actually here and here, I don't have room to show it, is 45 degrees. This is an isosceles triangle, which we have 45 degrees here and also here. Also here, we have 45. So now let's go back to our force, to our calculations. So we'll have minus force AB times cosine 45 equals 0. From here, we will take the force in AG equals to 25,000 plus force AB cosine 45. Let's go ahead and calculate the sum of forces in the Y direction equals 0, resulting 12,500 minus, we'll have the Y component of force AB, which is going to be FAB times sine 45 equals 0. From here, we will calculate the force AB equals to 12,500 over sine 45. Once you calculate all that, you will get 17,678 newtons. Now let's go back and calculate force AG by replacing the FAB in this equation. And once you do all the calculations, force AG equals to 37,500 newtons. All right. Now let's move on to our next joint. Let's go to joint G. So here we'll have force AG in tension, which we just calculated as being 37,500. And from my previous video on identifying the zero force members, we know that when you have two collinear forces, they must be equal and opposite in direction, meaning that this other force, without any other calculations, is also in tension and it's also 35,500. Let's move on to joint H, I believe, or F, which is similar to joint G, joint F. We have the same exact situation. We have 37,000 in tension, which is this member right here, meaning automatically that this member is also in tension and it's also 37,500. Now let's move to joint E. We'll have our reaction here, which is 37,500 we have this member FE, which is 37,500, and we know it is in tension. And then we'll have the force in member DE, which by looking at my joint here, it's most likely going to be in compression in order for this joint to be in static equilibrium. So let's calculate the force in member DE. We can do sum of forces in X direction equals 0, resulting FDE. The X component is, because we know this angle is 45-degree angle again, X component, it's cosine 45 minus 37,500 equals 0. From here, we would know that FDE equals to 37,500 over cosine 45 equals to 53,033 newtons. Now let's move towards node D. Joint D is formed of two collinear members, which, as we discussed before, this is 53,033 newtons. That means automatically that member CD will be also, let's say this is the force member CD. Let me just make sure it is CD, right? It is CD. automatically it is in compression and it equals to 53,033 newtons. And the same, similar to joint D, we have joint B. If we go to joint B, we have two forces in our node here in the middle. Let's go and look at force member AB. What was the force member AB? We got 17,678, and it was in compression. That means that the force member CB is automatically in compression in order for this node to be in static equilibrium and equals to 17,678 newtons as well. So now we know all the forces in each member. I would like to go ahead and calculate node C just to verify if we have calculated our force members correctly. So I'll go to joint C. I have the $50,000 Newton force going downwards. I have the 25,000 Newton force towards the right. Let's see what we have here. We have FCB in compression, and it equals to 17,678 newtons, and force CD, it is also in compression and equals to 53,033 newtons. Another thing that we know, if you remember up here, we had two 45-degree angles, which means that this angle is actually a 90-degree angle, meaning that I have these two angles here, 45-degree angles. It's a little messy here, but bear with me. These two angles are 45-degree angles. Let me clean up a little bit. Okay, it looks a little bit better now. So let's go ahead and do the sum of forces in X and Y directions to make sure that we have calculated our force members correctly. Sum of forces in X direction equals 0, resulting in 25,000 newtons. Plus, we'll have the X component of 17,678, which is 17,678 times, and the X component is cosine of 45. Next, we have minus 53,033 times cosine of 45. And if you calculate all that, you should get an approximate 0, which means we have calculated forces correctly. Let's also verify and do the sum of forces in the Y direction equals 0, resulting 17,678 times sine 45 plus 53,033 times sine, I will go ahead here, sine 45 minus 50,000 newtons equals approximate 0. If you get a value close to 0, it's because I have rounded up this force here. You might get 1 or 2, so that it's still okay. That is it for today, my friends. I hope I have brought some light into the method of joints for you today. If you found this video helpful, don't forget to subscribe and give it a like. This helps other people just like you find me. Also, don't forget about the freebie that I have for all of you with an engineering degree from outside of the United States. If you would like a free guide with step-by-step instructions on how to evaluate your education in this country, click the link below and you'll be able to download it for free. That's all. I'll see you next time. Keep on practicing.